Sure. Here's the text with proper punctuation. In the middle of the year 2022, the James Webb Space Telescope began its main goal, around 1.4 million kilometers from Earth. The Hubble replacement will look for the oldest light signals in space. It was imagined that Webb would look into the beginning of space, but within hours of the first images being released, it became clear that Webb was not seeing the origins of the universe. Instead, this telescope is showing images that demonstrate that our cosmological perspective on the world has been off base until now. With all the excitement, one discovery has almost been overlooked. In March 2022, when no one expected a grand revelation, the old Hubble telescope stunned researchers by imaging a star that came to be known as Arundel. Arundel is the most ancient single star ever seen by humans. Find out what Hubble, Webb, and the Star of the Dawn are about in this video. Before we share the thrilling facts with you, we'd like to ask you to leave us a comment at the end of the video. Tell us your opinion on the video and the latest discoveries in cosmology. In the future, we will reward our supporters' contributions with a heart, and we'll pin your significant post to the top so everybody can read it first. So, make sure you subscribe, like the video, and reference both at the start of your comment. We're looking forward to hearing from you. And here we go with Arundel, the most ancient star ever seen by humankind. An astonishing discovery, the whole world was already squinting at the impending star as part of the Webb mission, when astronomer Brian Welch of Johns Hopkins University announced the staggering find. In a picture taken by the old Hubble Space Telescope, researchers were able to identify the most ancient single star ever found. The object was initially given the somewhat technical-sounding name WHL0137LS, but this miracle later became known worldwide as Arundel. Arundel comes from early English and means morning star or rising light. If you know the books of the English writer J.R.R. Tolkien, the name probably sounds very familiar to you as well. There, Arundel is the morning and evening star, whose light gives eternity to the elves. So, this celestial body was given a rather magical name, and somehow, it fits the time of Arundel. Its age is estimated to be around 12.9 billion years. By March 2022, it was clear that this star existed around 900 million years after the Big Bang. At that time, scientists still expected that Arundel was probably one of the earliest individual stars that had been freely dispersed in space after the Dark Ages. The old light became apparent only by a phenomenon that space experts call the gravitational lensing effect. The gravitational forces of the upstream galaxy cluster WHL0137LS intensified Arundel's light so much that the single star became visible despite its tremendous distance. This effect can be compared to running a bent magnifying glass over a map. Individual segments are massively amplified while the surrounding segments swell. The galaxy at whose edge Arundel was found was named the Dawn Arc. Still, researchers expected they had moved closer to the cosmic sunrise with this discovery. But then Webb came along and everything changed. Webb clears up old ideas. If you follow our channel regularly or really love stargazing in general, you probably know that the big picture has been under a microscope since Webb's first picture. James Webb's deep field image revealed so many ancient objects that the Big Bang is now looking increasingly unlikely. If it existed, it nearly certainly didn't happen 13.8 billion years ago. Webb didn't just show us galaxies that shouldn't exist according to the cosmological perspective, but it also gave us another image of Arundel. In the deep field image, Arundel can be seen as a small dot of light. You can also see the ring of light in the picture, which scientists call the Dawn Arc. The brightly shining star in the picture is much younger than Arundel. You can guess by the blue-white light in this picture that the brightest objects are the youngest and closest, while the red, dim, and rather blurry light signals come from the oldest objects in the universe. Because of this picture, scientists were able to get a much better picture of the first light star. Arundel probably had a mass of around 50 to 100 suns and, therefore, belonged to the class of blue giant stars. We use the past tense here because, likely, Arundel no longer exists today. The lifetime of the first huge blue star monsters was very likely under 4 billion years. If the star still existed today, it would be around 28 billion light-years from Earth due to the expansion of the universe. Even the James Webb Telescope wouldn't be able to detect it. Therefore, Arundel's light traveled 12.9 billion light-years until it hit the observation reflections of the James Webb Telescope in the summer of 2022. Through the light signals, scientists can find new clues about the star's nature. Using the best estimation methods, Webb observed the star through 8 distinct channels, each of which could capture different perspectives in the light. Here is the text with punctuation added. Missions we presently check out, and what researchers have closed thanks to this new perception. Rendell's age. Stargazers decide the age based on the supposed redshift on its long venture through space. The star's light is extended, in addition to other things, by the development of space. Because of the expanding frequency, the light is moved more unequivocally into the red range. The more the illumination of a world or star is moved into the red area, the more far off the objects are, and the further back in time is the second when the light was discharged. The radiance of Endel has a redshift of 6.2, which relates to a period of 12.9 billion years. Before the revelation of this extraordinary star, scientists could just track down stars with a redshift of 1 to 1.5. Thanks to the gravitational lensing effect with respect to the age, Webb was able to confirm the Hubble perception information got back in March. The surprising iridescence Webb also returned to the iridescence assurance and reached a clearer conclusion than Hubble had already. As indicated by the most recent discoveries, Endel was, or alternatively is, a Type B star with a viable surface temperature of 12,000 to 15,000 degrees Celsius. These are not the greatest and most sizzling stars in the universe, but they are close. As may be obvious here, they are also a lot more brilliant and more smoking than our Sun, which is a G-class star. The brilliance of this star could have surpassed our Sun by up to 1 million times. At that time, the star should have had a mass that surpassed our Sun by a factor of 50. Right now, anyway, space experts can't say with absolute certainty that Endel is actually a single star. The light could also have been produced from a double star or from a multiple star system. The few heavenly giants that still exist today usually have smaller mates or are multi-star systems. This is in all likelihood because these huge stars have a surprising gravitational pull and thus prefer to draw in different stars to their area. Space experts coincidentally found that Endel is 1 million times more brilliant than the Sun. Accordingly, this star knocks against the Humphreys-Davidson limit, which is the experimental glow limit for all objects right now known in the universe. In short, one could also say that Endel is really more brilliant than it ought to be, as indicated by this scale. There are a few explanations for this. If it turns out that Endel truly is a single star with 1 million times the brilliance of the Sun, cosmologists would need to reset the Humphrey-Davidson limit. Endel was, by old grandiose perspectives, a star of the first hour of the universe. This first generation of stars was already alluded to as population 3. Until last summer, space experts still expected that the first stars in the universe were giants like Endel. Through an interaction considered early-stage nucleosynthesis, the principal chemical components, hydrogen and helium, were formed. These two fundamental components formed the original of stars. These stars probably had only traces of metals, while stars of later ages show a higher metallicity. In order not to misconstrue this term, one should be aware that in stargazing, all elements which follow in the periodic table after hydrogen and helium are considered metals. Thus, for the cosmologist, gold is a metal, as is carbon. Cosmologists believe that most of the stars of population 3 have died by now. The life expectancy of the giants was probably only 200 or 300 million years. The remaining remnants are faint and really challenging to notice. While obviously specialists are hoping the new telescope will find some more extremely old stars, what will we learn in the future? As mentioned at the start of this article, the James Webb Telescope has already tracked down a few galaxies that far surpass Rendell's age. Since these galaxies have shown up in the night sky, many things have come under a magnifying glass. The universe is, very logically, a lot more ancient than previously thought, or it began uniquely in contrast to what space experts and cosmologists had already envisioned. Galaxies which are 13.6 billion years old have already existed 200 million years after the Big Bang, and with these light signals it concerns obviously fixed and completed worlds, which were surprisingly glowing and massive. Assuming one follows past models of the Big Sack, there should have been, all things considered, individual stars in this time. Yet, no prepared galaxies, since stargazers have these new, acknowledged, normally also Endel moves into another light with a time of just 12.9 billion years. Estimated by the range of worlds, Rendel's position as a star of the grandiose dawn is essentially now obsolete. Once more, sadly, we can't currently distinguish individual stars in these now known, most ancient galaxies. However, it can't be precluded that future pictures of Webb and the gravitational lensing effect will lead to the discovery of even older individual stars that are still distinguishable today. Now, you tell us your thoughts on Arundel's revelation and the most recent discoveries of the James Webb Telescope. Do you think Endel truly was a star of the first hours? Or do you agree that something can't be correct about the past assumptions about the period of the universe? We appreciate your perspective. Also, remember to mention your subscription if you have one and to like the video. We're happy you joined us today, and we'll see you next time at Basically Space.